Okay, let me read the problem. This says a cannon of mass capital M starts sliding freely down a smooth inclined plane at an angle alpha to the horizontal. So we have an inclined plane. This inclined plane is smooth, so mu is 0 for this inclined plane. Mu is 0. Now this inclined plane is smooth. Mass of the cannon is capital M. And angle with the inclination, angle with the horizontal is alpha. After the cannon covers a distance h, so this cannon starts moving freely with initial velocity is 0, so here the velocity is 0. And this comes at a distance L. When cannon reaches here, a shot is fired, the shell leaving the cannon in horizontal direction with momentum p. So there is a shell that has been fired and this goes in the horizontal direction. So this shell moves in the horizontal direction. Let us say mass of the shell is small m and the momentum by which this is going, that is p, that is given to you. As a consequence, the cannon stops. So now cannon stops here. So velocity of cannon here is again 0. After the shot, before the shot this velocity was not 0. So this velocity is 0 after the shot is fired. After the shot has fired. Or you can say after the shell has fired. Determine the duration of shot. So we have to find what is the time interval for which the shot has been fired. Now to do this problem, what we will do is we will apply dp by dt is equals to F external. So this means if I know F external, if I know dp, I can calculate dt. So this is something, the same equation can be written as dp is F external into delta t. So if I know F external, if I know dp, I can calculate dt. And in this case, I will apply this equation in this parallel direction to the incline. So we are going to apply this equation. So let us call this equation 1. We will apply this equation in direction parallel to incline. In direction parallel to incline. So if I apply in the direction parallel to incline, we will get the desired delta t. I will give you 1 minute time. Let us think how will you apply this thing. First you find velocity. I will give you a hint. First you find velocity of this mass here. So what will be the velocity just before shot? So you find velocity just before firing. So what will be the velocity just before firing? Now see, the acceleration towards this is g sin alpha, everybody knows. Acceleration towards incline is g sin alpha and distance covered is L. So velocity will be under root 2gh. So under root 2g, g is basically g sin alpha and h is the distance covered, that is L. So this is the velocity just before the firing and velocity just after the firing is 0. Are you getting? So now let us do yourself. I will wait for some time. So let us apply this one. So before firing, I will have situation is something like this. This sail is coming down the incline. It has reached here, and now it has a velocity, and the velocity is given by this expression under root 2gl. So let us call this as a v1. So this is a v. This is going with velocity v1. So now this will have a momentum in this direction. Total mass is m. So momentum in the inclined direction, that is in this direction, momentum will be mv1, and v1 is nothing but under root 2gl sine alpha. So this is the initial momentum you have before collision. This is the initial momentum you have in the inclined direction. Are you getting? So pi, I can write pi is m into under root 2gl sine alpha. This is the along the direction of incline. Now let us say after the firing what you will have. So after firing, my situation is something like this. Question says this is going, cell is going with velocity v such that momentum is p. Now this stops. So what is the final momentum? Momentum of this is 0, but momentum of this is p, but this is in the direction of, this is in the horizontal direction. I need momentum in the direction of incline. So if I convert this into this direction, this angle is alpha, so this angle is also alpha. Are you getting or not? So this angle will also be alpha. So this will be p cos alpha. So in this direction momentum is p cos alpha. So momentum of this is 0, momentum of this in the direction of incline is p cos alpha. So this is again in the downward direction. What is the change in momentum? That is a p final minus p initial. P final is p cos alpha. So momentum of this block, the cannon, is p cos alpha plus 0. So this is p cos alpha, for this is 0. So finally p cos alpha minus initial momentum we have already calculated, that is m times this value, m times under root 2gl sine alpha. So this will be m times under root 2gl sine alpha. So this is the change in momentum. So this is the delta p. Both are in the same direction. So this is the delta p. So this is the change in momentum of cell plus bullet system. So this is the change in momentum of bullet plus cannon system. Now what are the forces that is acting, external forces that is acting on the cannon in the direction of incline? So in the direction of incline there is only one force that is acting, mg sine alpha. So I can write dp is equals to f dt. F external I know, dp I know. So dp I have already calculated this value. So I can write p cos alpha minus m under root 2g L sine alpha. So this is dp is equals to f external into dt. F external is mg sine alpha. Mg sine alpha into delta t. So duration of shot can be found from here. So dt will be simply p cos alpha minus m under root 2gl sine alpha divided by mg sine alpha. Now I ask a simple question. Why not we have done the same calculation in the perpendicular direction to the incline? Why we have not done this equation, that is dp is equals to f external into dt? Why not I have applied in the direction of perpendicular? So you see, why not I am applying this equation in this direction, that is the perpendicular direction of incline? Why not I am applying in this direction? Can anybody give me the answer? Answer will be easy if you understand the forces that is acting. Now see, if you want to apply, in that case, the external forces, that one external force I know, that is mg cos alpha you will have in this direction, and another force that also you will have, that is normal reaction. So in the perpendicular direction, there is one other force, normal reaction I will have. So F external in the perpendicular direction will be n minus mg cos alpha. But the normal reaction is not known. Are you getting or not? So to finding normal reaction, there is another unknown. If I apply the same equation in the perpendicular direction, I will not get the time duration, because normal reaction, that is another unknown. And that's why initially I have not considered dp is equals to f into f external into dt formula in the perpendicular to the inclined direction. If I consider the moment, this change in momentum in the along the direction of incline, I can easily calculate dp. I can easily calculate dt, because in that direction only one external force that is acting. There is no external force. Since friction is not there, I will have only external force that is acting is mg sine alpha. So it's easy to consider the motion along the direction of incline. We'll discuss the next problem of the same kind. Let us finish it here.